This video covers section 7.5, which discusses how to solve a rational equation. So here we have outlined the steps. The first step will be to clear all the fractions by multiplying everything by the LCD of all the denominators that we see in the expressions. After we clear the denominators, then what we'll be left with, in these examples at least, will be either something that's linear or polynomial. And depending on the type of equation we're left with, we'll take the appropriate action to solve that equation. And then this last step, normally the check step is optional, but in this type of equation, we can actually introduce solutions that are not actual solutions. So we will generate, in the first two steps, a list of eligible solutions, and then in the last step, we'll determine whether some of those eligible solutions are actually not solutions to the equation by checking to make sure the denominators are not zero. So let's look at some examples. In the first example, all of our denominators are just constant. So the first issue is to figure out the LCD. If we're looking at 3 and 5 and 15, the least common denominator for those three should be 15. So we multiply on this side by 15 and also on this side by 15. And then on the left we have to distribute because there's a difference that we're multiplying by. And on the right we'll just get 1. So on the left we'll have 15 over 3, which we can reduce to 5, times x plus 2. And then we'll have minus 15 over 5 times x minus 1. Right? So we'll have 5x plus 10 minus 3x plus 3 equals 1. The equation we're left with here is linear because we don't see any x squareds or x cubed. When we have a linear equation, we want to get like terms together. So we'd have 2x plus 13 equals 1, and then move the 13 to the other side. So subtract 13 from both sides. 2x is negative 12, so x would be negative 6. And then we check, and if we put negative 6 in, that doesn't make any denominators 0. So it's an actual solution. In a few of the later examples, we'll see when we have a proposed solution that does not actually solve the equation. Here, our denominators are x, 2, and 2 times x. So the least common denominator would need an x in it, and it would need a 2 in it, and that would cover it. So just 2x. So multiply by 2x on the left and the right. Again, on the left we need to distribute. So we'll have 4x over x plus 2x over 2 is, on the right, the 2x's cancel each other out to make 1, so we'll just have 5. There we can cancel the x's. Here we can cancel the 2's, so 4 plus x equals 5. What we're left with is linear again. So we just group the like terms together and get x alone on one side. X is 1. And again, if we check putting x equals 1 does not make any denominator 0. So we'll keep it. Next examples. Here we only see one denominator, that's x. All the others have denominator 1. So our least common denominator would be x. If I multiply by on both sides by x, this time I need to distribute on both sides because I've got a sum originally. So I'll have 2x plus 6x over x equals x squared plus 7x. And now, because we have this x squared, we know we're going to take a different approach. We're going to need to work with our quadratic equation approaches. So these x's we can reduce. So we've really got 2x plus 6 equals x squared plus 7x. So now we want, because it's quadratic, we want a 0 on one side. And then we'll factor. That's always our approach if we have a quadratic equation. So I'm going to put the 0 over here, subtract 2x and subtract 6. That'll leave me with x squared plus 5x minus 6 equals 0. I guess I have equals 0 on both ends. We don't need that. So we can factor x plus 6 times x minus 1. So the solutions would be x equals 1 and x equals negative 6. And again, the only thing that would make this denominator 0 is 0 for an x value, so these are fine. They don't make any denominators 0. I promise, in one of these examples at least, we'll see where a denominator is 0 and we need to cross out a solution at the end. Okay, next one, the least common denominator would be a group this time, x minus 1. So we'll multiply by x minus 1 on the left and on the right. This time it's on the right that we'll distribute because we have a sum. On the left we'll just cancel the x minus 1 factors, so we'll just have 5x equals 5x minus 1 over x minus 1 plus 3 times the quantity x minus 1. So here we can reduce those. So we're left with 5x equals 5 plus 3x minus 3, linear. So we can get the x's on one side and the constants on the other. If I subtract 3x, that'll give me 2x equals 2, which means x equals 1. But here's an example where that value that we came up with makes the denominator 0. So we don't get to keep it. So there are no solutions because the only possible solution gave us a 0 in the denominator. Right, so if you have a proposed solution that gives you a 0 in the denominator, that is not actually a solution because it would make the original expressions undefined. So in that example, we have no solutions. Next one, again, we have a group as our least common denominator, x plus 3. So we multiply by that on both sides to clear the denominators as the first step. Now when we distribute, we'll have x times x plus 3 minus 6 x plus 3 over x plus 3, which we can reduce, equals 2x times x plus 3 over x plus 3 plus 2 times x plus 3. And then reduce what we can. We can take that out of the way and that out of the way. And simplify what's left. So we've got x squared plus 3x minus 6 equals 2x plus 2x plus 6. And again, because we see this x squared, that should say right away, get 0 on one side and try to factor. So if we rearrange to get 0 on the left side, this time we'll have x squared. We'll subtract 4x, so minus x, and subtract 6, so minus 12 equals 0, which we can factor as x minus 4, x plus 3 equals 0. And then finally, x equals 4 or x equals negative 3 would be our possible solutions. But negative 3 makes the denominator 0, and 4 does not. So we keep 4, but not this one, because it makes the denominator 0. Right, so there's one solution, x equals 4. All right, example F. First, before we choose the LCD on this one, we want to factor everything that's here. This x squared minus 1 we know factors as x minus 1, x plus 1. So our least common denominator would involve 2, x minus 1, and x plus 1. So LCD 2 times x minus 1 times x plus 1. So I'm going to rewrite the original equation with the factored denominator. So that's my original equation, and now I'm going to multiply by the least common denominator on both sides, which is 2 x minus 1, x plus 1. And distribute on the left at least. So we'll put that with this group and with the second group. So I'm going to have 4 x minus 1, x plus 1 over x minus 1, x plus 1 minus 2 x minus 1, x plus 1 over 2, just multiplying numerators and denominators together. Then on the right side, I can cancel those. So I'll have 2x plus 1. Right. Then I'll reduce on the left, get those, and the 2's. We want to be really careful here about the order. We need to multiply before subtracting. Right. Order operations would tell us that. So what we need to do is subtract the whole product. So we have actually 4 minus the group x squared minus 1, which is what we get if we expand that polynomial product. And on the other side, 2x plus 2. So 4 minus x squared plus 1, if I distribute my negative, equals 2x plus 2. And again, because of this x squared, we know we want to get a 0 on one side and then factor. So this should be our last step. If I get a 0 on the left side, because I want the coefficient in x squared to be positive, I'll have x squared plus 2x. I'm going to subtract 5, so that'll leave me minus 3. And if I factor, that's x plus 3, x minus 1. So as a last step, we've got possible solutions, x equals negative 3 or x equals 1. And finally, we search to make sure they don't make any denominators 0 this time. This one is fine, because x equals negative 3 won't give me a 0 in any of the denominators. But x equals 1 is not good, because that makes denominator 0. Few more examples. Here our LCD would need x and x plus 4. Remember, x is not a factor in this expression, x plus 4, but it's a term. So we need LCD to be both of those factors, x and x plus 4. So multiply by that group on the left and the right. And we don't have to distribute this time because we only have one term on each side, or one group. So we can just cancel the x's over here and the x plus 4's over here. So on the left, that's going to leave us 3x plus 12. And on the right, we'll multiply x plus 2 with x to get x squared plus 2x. And again, we see that x squared, so get 0, then factor. And that's going to leave us x squared minus x minus 12 if we subtract 3x and 12 from both sides. Factoring that leaves us x. We know the signs will be opposite, so minus and a plus. And we want a negative in the middle, so we want the 4 to be negative and the 3 to be positive. Right. So then our solutions, we've got x equals negative 3, or x equals 4. And this time both of those eligible solutions actually are solutions, because neither will make a denominator 0. 4 isn't a problem, right, because that denominator would be 8. So both solutions are fine. No zeros in the denominators. Again, on these next two examples, we're going to need to factor the original denominators before we choose the LCD. We saw this denominator in a previous example that factors as x minus 1, x plus 1, because it's a difference of squares. So we'll multiply by that group on both sides. On the right, it's just going to cancel, and we'll get 3x remaining. And on the left, we need to distribute. In the first group, the x minus 1s will cancel each other out, so we'll have x plus 1. And then we're going to subtract the whole quantity that comes after the subtraction sign. So we're going to need parentheses. The x plus 1s will cancel each other out, so we'll have x minus 1 in parentheses. And then carefully distribute that subtraction, so we've got x plus 1 minus x plus 1 equals 3x. So the x's drop out on this side, so we've got 2 equals 3x, so x should be 2/3. And the only thing that would make a denominator 0 would be 1 or negative 1, so we keep that value. It doesn't make a denominator 0. And this is the last of the straightforward kind of equation solving. The next examples we'll look at are equations that involve several variables, and we'll be trying to solve for a specific variable. One more of sort of just the standard type of equation. First, always factor everything in the denominators. Our LCD would need to involve a 2 and an x plus 1. And a 4, but 4 has a 2 in it. So if we just take 4 and x plus 1 as our factors, that should be great. So that will be our LCD. So we've got 4x plus 1 times the left side, and also 4x plus 1 times the right side. So on the right, we'll just have 4 times the group x minus 3 left. And on the left, in the first group, we can reduce the 4 over 2 to make a 2. And the x plus 1s will reduce, and the x will be left. And in the next group, the 4 and the x plus 1 drop out, so we'll just have 2x minus 6. This leaves us 4x minus 6 equals 4x minus 12. And here we run into another strange thing. Now we've got what's called a contradiction, because the variables drop out and what's left is a false statement. Which what we will say is there is no solution. And I'll write down again what that contradiction is. So a contradiction okay, so a contradiction, that's where we were, is anytime the variables disappear and what's left is a false statement. In that case, we always say no solutions. So that's what happened here. It was different than those situations in which we had proposed solutions, but they made denominator 0. This time we just didn't even have any proposed solutions. Nothing was going to make this equation work. All right, so then the next few examples are what are called literal equations. And what we're trying to do is solve for a specific variable. And if what we have at the start is a rational equation, we start the same way we would with any rational equation. We multiply by the LCD to clear out the denominators. In this case, the LCD is x times y times z. So if I multiply both sides by x, y, z, on the left I have x, y, z over x plus x, y, z over y. And on the right, I have x, y, z over z. Then we'll reduce what we can. The x's in the first expression, the y's in the second, and the z's in the third. So now I'm looking at yz plus xz equals xy. And this is where it can get confusing. We're trying to solve for x, so it helps to sort of make some indication of like, this is the variable I care about. And then we want to get all terms involving the specified variable, in this case x. So get all terms involving x on one side by addition or subtraction. So rearrange things. So let's subtract xz from both sides. Doing that, we'll leave yz equals xy minus xz. Now at least we've got both of these x expressions on one side. Then we want to factor out the x. So yz equals x times y minus z. Now at least we have x just in one place, and we'll divide by y minus z. So we'll have x equals yz divided by y minus z. And we're done. Right? So what we want is x on one side and no x's on the other side. That's our goal. So x alone and no x's on the other side of the equation. Here, if we're trying to solve for little t, we would again multiply first by the LCD, which is t plus b. And that looks just like cross multiplication. So if you're thinking, seems like I'm cross multiplying, you are. It's the same thing. We're just multiplying by the LCD and calling it that. So we'll have I times t plus b equals a. And I want to get to this little t somehow. So I could distribute, or I could divide by I. I would divide by I. Let's do that. So then I have t plus b equals a over I. And then I want to get that b out of the way. To undo addition, I would subtract. So t is a divided by I minus b. Right, so to undo addition, I would subtract. To undo subtraction, I would add. And to undo multiplication, I would divide. And to undo division, I would multiply. Right, and that's true throughout these operations. If I'm solving for capital G, if I multiply everything by capital G first to clear out the fractions, since that's my LCD, I'll have G times N equals RG plus v. Then I want to get all g terms on one side. And to move a whole group, I would subtract or add. So I'm going to subtract capital R times capital G. So I'll have G times N minus R times G equals V. Then factor out the G. And then divide by N minus R. And we're done. So that's it for section 7.5. There was a mistake in my work on example I from section 7.5. I miscopied one thing from one line to another. Right here, when I moved to the next line, I had 2x minus 6. It should have been 2x minus 16, which makes 4x minus 16. And negative 16 equals negative 12, which is still false, and there's no solution. But just in case you were wondering, I did have a mistake right there.